I'm working for democratized AI and also environmentally friendly AI. And I'm very excited to be doing that in businesses, helping business experts actually work with AI. Without explainability, AI is just a dream. It's unreachable, but ease of use and explainability brings AI to the footsteps of the business experts.
Episode of Engati CX. I'm your host Shweta, and we're glad to have you with us today. On this show, we talk to CX and technology experts from around the world. We explore, uncover, and share fresh insights on creating experiences that your customers will remember and look forward to. Engati is the world's leading multilingual, no-code digital CX platform, available across 14 channels with 45,000 solutions created across 186 countries in every domain and use case. It has been recognized as a top platform by Inc. magazine, Tech World, CIO magazine, and many others. We run the Engati blog, the video channel, and the CX podcast, receiving upwards of 400,000 visitors annually. And now for our guest, Zehra Cataltepe is the co-founder of Tazi.ai, which is a Gartner Cool vendor in core AI technologies. She has been recognized as the Woman Entrepreneur of the Year in the years 2019 and 2020. She helps create AI expertise within insurance companies so that you can create your own solutions for the complex and dynamic insurance world. She also holds expertise in insurance companies reduce fraud, increase profitability, and increase customer retention by means of creating one-click, deployed, explainable, and actionable solutions. Welcome, Zehra, and we're glad to have you with us.
And I'm really glad to be here. Thank you so much.
Yeah. But before we dive into our interview, please don't forget to subscribe to Engati and tap the bell icon to get access to exclusive content from great leaders throughout the world. Okay, so beginning with the interview, Zehra, the first question we have for you is, do you foresee Auto ML graduating with a no-code approach to solve AI problems?
Yes, definitely. And we actually evolved from an AutoML platform used by data scientists into an AutoML platform which was no code and required you not to be a data scientist and not a software engineer. And actually, that's the way to go. It has to be no code. The analogy I have for that is you don't have to be mechanical engineers to drive cars. And just like that, you don't have to be a data scientist. You don't have to be a software engineer to be able to use AutoML platforms. And what I see more and more is the actual complexity is actually in business, because I'm by training I'm a data scientist. So of course, for me it's a pleasure to make an algorithm 99% accurate as opposed to 97% accurate. But when I realize, and it has been always our experience that when we deploy the systems, there are so many complexities of business, and only the business experts know those complexities. So we decided to actually be no code so that everybody from the business process could be included in the creation of the AI model, but not only that, in the deployment, in the correction, and in taking actions. Everybody should be included. So it's like, it takes a village to raise a child, and I do see the AI models kind of like apprentices who are doing certain tasks in business processes. So of course, AutoML has to be no code, because when it requires coding, it always excludes the business experts who really are the real stakeholders when you deploy the AI models in live business processes. And another thing that we have found out is inclusion of business experts is also necessary. In other words, being no code is necessary because business conditions always change. So if you leave the creation or the update of the machine learning model to only data scientists, then when the world changes, you will always put lots of load on the shoulders of your data science teams. On the other hand, if you take certain tasks to observing whether things have changed, how to update the models, how to monitor the models. If you put certain tasks on everybody's shoulders, then you are also going to have better deployed models. So for that reason, AI or AutoML platforms will have to be definitely no code and definitely easy to use. Because otherwise they will be just data scientist experiments, which actually do not find an audience in the business circles, who are the real decision makers, who are the real people who should be benefiting from AI at the first place.
All right, yeah, makes sense, definitely. Okay, so the second question that we have is that we've seen in model drift that the predictions sort of become less accurate as time passes. So is there any way in which AutoML could address this problem and sort of help to solve it?
Yes, sure. Actually, this was the reason why we established Tazi. So, so we're a husband and wife company, and at first I didn't want to, start a startup with my husband, right? Because you don't want to put all your eggs in life in one basket. But Tanju was so determined to solve the model drift problem. We ended up establishing Tazi. Our purpose was to make sure that we have an AI system that continuously adapts as data and underlying business conditions change. So, I'll use my hands. I actually have a graph for that, but I'll use my hands because I just maybe that's more interactive. So what happens with a model that learns from a static problem like apples and oranges and identifying those is you gather lots of apples and oranges, cats and dogs don't change most of the time. But when you are dealing with real business problems like customer churn, claim fraud, economy changes, your competitors change, your product changes, your customers' behavior change, and regulations change as they happen. Even your definition of customer churn changes, and underlying dynamics of churn, for example, changes. I'm just giving churn as an example. So what continuous learning does is, maybe I'll tell you what batch learning does first. So you gather the data, and then you train the model, you test the model, and you're happy with the model, so you deploy the model. And then, just like, we will all die once are deployed in real life business situations, will degrade over time. And everybody knows that they will degrade because everybody knows businesses change. So the usual practice in batch machine learning is you watch the model drift. You watch its performance get worse and worse. And at a certain threshold, you say, this model is not usable anymore. Let me collect the new data and let me train a new model and deploy that model. But that doesn't really work for a number of reasons. One of them is then it will take lots of time to develop a new model for you, and you are going to first of all lose that much benefit. You have erred in that period. You have lost customers. You have been exposed to fraud. So you lost business while your model was drifting. So continuous learning allows you to adapt to change while it's happening. So you learn from today, as opposed to waiting for tomorrow and then saying, oh, I made a mistake, and then learning from it. Another reason why you need continuous learning to address model drift is explainability. Because when you include business expert You have to have explainability, you have to have interpretability in your models, because business experts will not take actions on your models unless they understand what's happening with them. So when you have one model trained on one set of data and another model trained on another new set of data, here's what happens. For that model, you are going to create a set of explanations. And for this model, you are going to create a new set of explanations. And as you know, the machine learning models are chosen among infinitely many possibilities. So I can create a neural network for you as a solution, but there are infinite many neural networks who are just as good as the one that I have given to you. So there is no guarantee that the new model will be, even the new model's explanations will be anything related to the old model's explanations. So when that happens, business just loses trust completely in AI, because they will say, oh, you said this as the explanation to me yesterday, and now you are telling me this today? No way. I mean, we have seen, even when one variable changes, we have seen our customers like go, I want that explanation. I don't care if it is not that accurate. I want explanations similar to what you have given to me. Because as human beings, we can start reasoning about things only when we establish a baseline. And if that baseline is suddenly, evaporated and something else is put in, we lose trust and we are not going to want to use that AI system anymore. So to address the model drift problem, you have to have continuous learning, but it's not just continuous learning. You have to have robustness in those systems, because as conditions change, you want to make sure that you have a capacity in your model, but also simplicity, because you don't want to overfit anything. So we found out that use of ensemble learning and use of feature selection are very crucial. Those technologies are really must, because as change happens, essentially you don't really have tons of data. You might have terabytes of data, but you just have a small number of observations about the new types of things happening. So you have to have simple models and models that can actually evolve in time as you have more and more observations. So continuous learning models, again, are a must for drift. And another thing that we have found out is local models and global models should be used together in ensemble models, because local models have the benefit of, if not the whole world, but a portion of it has changed, then the local model will learn that part. Only the change will happen in that part, and the rest will be more or less the same. So you'll have a better adaptation to what's happening, as opposed to a global model. So those are all our expertise or know-how that we have gathered so far in using continuous learning models in industry. And we'll talk about that, but another thing that we have found is actually getting feedback from the experts is also crucial for model. You don't really have data about the change, but you have, you know that it will happen. An example that I use for that is, if consider two pizza shops, one in Palo Alto and the other one in Los Gatos. In Palo Alto, not many Stanford students anymore, so those pizza shops will deliver much less. And in Los Gatos, people will be ordering a lot more because they are in their homes. So if you're an auto insurance company, you should be reducing the premiums in Palo Alto, because those cars will be used much less, but the ones in Los Gatos will be used much more, so you should increase the premiums. So that knowledge is actually in the head of an insurance expert, and you need human-in-the-loop technology so that your models can learn from the future. Models for that future, even before you observe anything, any data about that future. So those are technologies that we are using to address the model drift.
Okay. That's great. Another question we had is that, as opposed to the concept of black box, when do you think that we can have explainable AI, especially when it comes to deep learning models? So, when do you think that we can have explainable AI?
Deep learning is a great technology, as we all know, right? So it has worked wonderfully, especially in things like audio, video, image, text. Great things have happened, and they will keep happening. So I have what I find out is using especially for example, variational autoencoders, or in general autoencoders, clustering techniques on the features produced by those models to determine things like, for example, I say that there is a tumor in this picture because of this part of the image. So those models, those deep learning techniques allow you to tell the human expert the reasoning in terms of what the human expert knows. So we need deep learning models to have the same vocabulary as the human expert who works in that field. And the way to do that is to basically get all the segmented images, and then cluster them, and then learn their groups. And then based on those groups, when a new image comes in, you are able to tell the expert, I think that there's a tumor here, or this is a malignant tumor because of the following feature. So it all boils down to making deep learning models talk in terms of what the domain expert understands, and we can actually achieve that. The same thing can be done with audio, the same this for video as well as text. So we can actually explain what's happening underneath, especially given enough data. We can explain what's happening reasonably well, but not all the time. So there will be times when we are not going to be able to explain what's happening with the deep learning models, because they are very complex. So for that, I can offer two solutions. One of them is divide and conquer. So instead of, maybe I'll go back. So you should always keep track of how good your explanation is. So you should keep track of the performance of your explanation, which is what we do all the time. So we always tell you, your explanation model has the following confusion matrix with respect to the actual model, because explanations are not usually as complex as the underlying model. So they will make errors. So one good approach is, in my opinion, to divide and conquer, in a sense that you explain not the whole model, but portions of model, like think of Lime or Shapley, for example. But instead of just linear combination of features, you can explain more complex ways. And the other approach I suggest is, again, being able to say that when you cannot explain, being able to tell that to the human expert, and letting him or her know that I decided, as a neural network, I decided, but the explanation I have given to you is just an approximation, and it's not enough. And one last thing I should say about explanations is the explanations have to be simple enough. So set explanations, but if they are too complex, they are too complex for the human expert who's working on that domain. They are not going to use those explanations. So you have to live with an explanation model, which is an approximation to the underlying model, but which is able to give to the human expert the trust that the model is not doing something funny or unexpected, and also the ability to understand how things are happening, have an idea on how things are happening. So explanations are really approximations, and we should always keep that in mind. They are not going to be 100% accurate ever, actually, in my opinion.
Okay, so like you just spoke about the example of the tumor that you just gave us. So there could be circumstances wherein there's some sort of a lack of trust from the end users when it comes to the model. So how do you think that we can bridge this gap, the deficiency of trust? How do we bridge this gap? How do we make them trust in the model more?
Sure, sure. Mm, I mean, I feel like we are at the beginning of a dance here. Okay, so uh, it's like the machine learning models and the human business experts who are using them, they are having interactions, and what we have right now, things like, GA2Ms, surrogate models, Shapes, lines, features, these are all tools. And we are going to have more and more specific explanations and specific types of interactions and explanations between models and users for specific business problems, and even for specific points in business processes. So we are going to see, we are going to see trust building as we create explanations that make sense for the user. So a friend of mine had told me, he teaches at Purdue University. He said there could be online teaching, but I don't know if it is online learning. So I could explain something, but if the human, we could have an explanation, but if that explanation is not understood by the human expert, it is meaningless. So the same language, speaking the same language as a business expert, using variables, indicators, types of explanations that the user is accustomed to is really key. And what I have seen is we, or no, human business experts, at least now in insurance and in finance, we have lots of experience with different lines of business. What I have seen is when a business expert looks at the explanations that we provide, they want to see basically two things. One of them is, actually three things. One of them is the model using the variables that I would use as a human? The second is, are the explanations close to things I have observed so far according to my years of business experience? So these are trust. And then a business expert would use a machine learning model only if it adds up to something, if it adds something to their knowledge. So they want to also be surprised, but reasonably surprised. So the machine learning explanations should teach them things that they didn't know, but they suspected. So new patterns which make sense and they weren't aware of. So I have seen those to actually enable trust between a business expert and the explanations produced. And finally, I also have seen ease of use again being very important. If I just explain things to you, okay, and you're not able to access to it, it's like you are behind a glass wall. You are seeing things happening, but you can't do anything about it, right? So explanations like that are useless. You need the business expert to be able to easily use the AI system, so that if the explanations show that AI is not doing something right, then the business expert himself or herself should be able to just go in and change the model which is not working. And another thing which is needed is, obviously, not just ease of use, but also human in the loop. So not just the ability to change the way the model was created, but also the ability to update the model based on the expertise of the human expert, but being able to do that even if that person is not a data scientist. So you need all of that for trustable, explainable AI.
Yeah. And on the similar lines, like how do we sort of develop common sense and reasoning in AI using self-learning techniques? How do we bring these two when it comes to AI?
It's a huge question, right? So self-learning, like I worked on semi-supervised learning methods a lot, and of course, when you include self-learning, you always have to be careful about where your models converge to, and whether what the models are doing are consistent or not with what's happening in the real world. So we do use self-learning, especially active learning, is something that I have experienced with a lot, and I really believe that it works. So common sense and reasoning are really huge words. Okay, so first of all, I want to not I mean, definition of common sense is very difficult. So right now we are hoping to use our AutoML to solve business problems, really. So common sense is huge, and I think common sense, to be honest with you, right now lies with the humans, and we can have AI models that make sense in limited domains, but as soon as we try to open those up, we need tons of data and tons of computational power, and we do have them in certain areas, but we're not going to ever have it in many other areas. So I want to separate that, but I'm a believer in semi-supervised learning methods, especially active machine learning, and we have seen that using active machine learning, we are able to reduce the required labels by more than like 70. If you have our active learning, your model will be ready in like 1 day. If you don't have it, it would have been ready in 4 days. You would have to wait 4 days of collecting data. And that all happens because active learning enables the AI models to be like a good students. So they can say to the human experts or to the outside world, if you were to give me the labels for these instances, I would learn so much better. And then those labels are provided back to the AI, and they do learn obviously a lot better. So yeah, I mean, we are going to be seeing more and more of course, different types of self-learning.
Yeah. Okay. And when it comes to machine learning observability, what do you think are the best practices for it?
That's a tricky question. So when you say observability, I presume you mean machine learning operations. Is that right? I mean, like I have created a model, I have deployed it. What's happening with my model?
Yes,
okay.
yeah.
So that's a must. I mean, if you are going to have an operational machine learning system, first of all, you have to have that machine learning system creating performance metrics continuously, and not just machine learning KPIs, but also business KPIs. So for example, you should see these are the number of false positives, and this is the cost of those false positives, and those costs are always business dependent. So you have to have the performance spoken in the language of the business user, and in terms of the benefits or the risks to the business user continuously. But it's not only that, you need to be able to kind of plug and play the machine learning systems. So if something doesn't work, you have to easily be able to deploy the new version. We are we always have not just an ensemble of models in our single installation, single solution, but we always actually recommend having multiple solutions continuously learning. So if one fails, you have the other ones to be, and of course you should be able to just put the new one in a very easy way. Another thing that we believe in is having backups. So we always keep continuous backups of the models so that if anything goes wrong with your current model, you are always able to go back and continue from where you left off. And another very important thing is auditing your machine learning system. So you know who has accessed it, who has done what change, and we use lots and lots of reusable inputs, outputs, configurations, data profiling results, and dashboards. We always have them reusable so that you are able to share them in a group of business experts and data scientists. And if something happens, if you are sick, for example, today, I can actually continue working on your models because everything is there with the configurations, deployment scenarios, and everything. So I can work instead of you while we are absent. So all of these are must, especially if you are going to use AI systems in financial institutions, in healthcare, in insurance systems, because otherwise again they're not going to be usable in practice. You'll run into auditability problems, regulations, and all of that, and also continuous operation will not be feasible unless you have the appropriate machine learning operations. So this is what we decided to have. All of the modules that we are using right now happened because our customers required them in insurance or finance domain.
Okay. Also, we've been seeing the concept of knowledge graphs, like we've seen Google makes use of it in order to provide us with relevant results. So how can ML models use this in order to accelerate their learning? So how do the knowledge graphs come into picture here?
I guess I'm old enough. So when I just want us to be all aware of the fact that as soon as you introduce knowledge graphs, or like there were ontologies, for example, we wanted to be able to use ontologies a lot, and they didn't work because we couldn't maintain them. So I think knowledge graphs, of course, have a future. But again, we will have to keep track. We will have to have mechanisms to keep track of different versions of truth. Just like if you have a rule-based, if you have a rule set, how do you make sure they are consistent? How do you make sure that they are updated? All of those problems, I think, will be the problems with knowledge graphs as well. Tazi is involved in a Horizon 2020 project called Tazi.ai. We just started in October 2020. And there we are actually using genetic algorithms. Our partners, actually, they are using genetic algorithms to create very interesting learners. And they actually allow you to create kind of decision trees, but those decision trees have ability to use different forms of expressions. So as opposed to just saying, I have a continuous variable, if it is less than this branch left, greater than that branch right, you have all different kinds of mathematical expressions that you can use when you branch from one factor to another. So I think, symbolic learning will be used so that we are able to take into account experts' knowledge in different ways. But it's a very new area. There are too many possibilities. Those models are very, very capable, and they could overfit very easily. So there will be problems that will need to be solved. So I would say, yes, knowledge graphs are important, but how do we maintain them is something that we will all have to think about, and I'm sure we'll take lessons learned from the past. And I really think that there's a future in symbolic learning, because it's as opposed to saying, oh, I have a deep learning neural network, please explain it to me. Instead, it is, I want you to learn in this way because that's the only way I understand. So it's going to converge towards that, not everywhere, but in some areas. We are going to see convergence of machine learning models to learn, to be forced to learn in ways that they are explainable by design.
Okay, I guess it was a great discussion, and I think I got to learn a lot. So, in conclusion, is there something that you'd like to share with our audience, or any last concluding words that you'd like to share with the viewers that are currently viewing this?
Well, first of all, thank you for listening so far, and thank you for these great questions. I would like to, first of all, share this excitement, because I really think we are at the brink of a change, and we are all going to learn different ways of dancing with the AI systems, and we will create beautiful ways of interactions. So I'm very excited about what will happen with explainable and usable AI. The AI that we are creating at Tazi is AI that is continuously learning, and each of these, underneath, there are huge technologies that we have to build. I'm a strong believer in explainability, because explainability is the only way AI systems will be used widespread in many different industries, in many, by many different types of people. So explainability is a key for democratization of AI. And I want to just conclude by saying that continuous learning is also a must if we want AI systems to be environmentally friendly. I have read a recent article which said that the Bitcoin mining versus deep learning, those are, and when I see those, I feel like what we did with cars, right? We ruined the environment because we use the wrong type of designs and wrong type of fuels. So hopefully everybody will learn continuous learning in deployments, so that as opposed to, oh, I have lots of computational power, so I'm going to create a model, and when new things come and the world has changed, I'm going to destroy that model because I have lots of computational power, and I'm going to create a new model, and I'm going to spend lots of cloud sources, lots of energy. I don't care because I'm a rich person, I can afford it. So hopefully we are not going to say that. Hopefully we are going to be more conscious of how much energy AI systems use and how environmentally friendly they are. And only if we do that now, when we have many of them, as we have lots of cars now, only if we do it today, we are not going to have to clean up after the AI systems, just like we have to clean up after cars today. So that will be my concluding remark. So I'm working for democratized AI and also environmentally friendly AI. And I'm very excited to be doing that in businesses, helping business experts actually work with AI. Without explainability, AI is just a dream. It's unreachable, but ease of use and explainability brings AI to the footsteps of the business experts, who are the kings really, because or queens, because they are going to be users. They are going to be making use of AI systems in their real life problems.
Yeah. Okay, so thank you so much. Your insights were really, really valuable, and I hope and I believe that all of the people viewing this would be really enlightened by this interview. So thank
I
you.
hope so.
Thank you so
Thank you
much.
so much, and I hope this wasn't a waste of time. So thank you so much for this beautiful set of questions. It has been a pleasure talking with you. Thank you so much.
Thank you. And we'll be back with a new episode. So stay tuned and we'll see you around the next time. Thank you. Thank you so much.
Thank you.